Welcome to another deep dive, and today, oh boy, are we going deep.
Yeah, this is a big one.
This one is really big into quantum physics.
That's right.
So strap in, everybody, because things might get a little weird, but hopefully a lot of fun, too.
Yeah, I hope so.
So we're using an excerpt today from a text called Quantum Physics, the Nature of Reality and the Limits of Human Understanding. And I love that title.
Yeah, it's a good one. Very descriptive.
It is. And it's exactly what we're going to try to do, to just really understand how quantum physics revolutionizes our view of reality and the universe, and touch upon all the philosophical questions that it brings up about existence and our place in it all, the big stuff.
The big questions.
Yeah, and the thing is, quantum physics can seem really, really intimidating.
Oh, yeah, it has a reputation.
But our goal today is to just make it accessible, break it down.
Yeah, make it fun.
Make it fun, right? So let's set the stage here a little bit. Before we can even really dive into quantum mechanics, we need to understand why it even came about in the first place. We had classical physics with all of its laws, and they seemed to work really well for centuries.
It was a pretty good run.
Yeah, so what happened?
Well, you got to imagine, right? Physicists at the beginning of the 20th century, they had this beautiful model of the universe, or so they thought, but then they started looking closer, like way closer at the world of atoms. Super tiny, and the subatomic particles, and that's when things just started getting really weird. Like they were putting together a puzzle, thought they knew where everything went, and then bam, they find this extra piece that doesn't fit anywhere.
Like, what is this?
Exactly.
Yeah.
And that's where quantum mechanics comes in. It offers this whole new framework, this new way to understand the universe at that super small, most fundamental level.
So it wasn't that classical physics was like wrong.
Right.
It was just
incomplete.
Yeah. It worked great for describing the world that we see, the world we experience every day.
It does a pretty good job at that level, yeah.
But when you get down to the tiniest scales, it falls apart.
Falls apart.
Yeah. Yeah, okay. And so quantum mechanics comes in to try to explain those strange things that classical physics couldn't account for.
Exactly.
Okay, and one of the big things that came out of that was this concept of wave-particle duality. And that just sounds like a paradox.
It's a head-scratcher for sure.
How can something be both a wave and a particle at the same time?
Right. It's a concept that really messes with our intuition.
Totally.
So think about a beam of light, right? Sometimes it spreads out like waves on a pond.
Okay, I can picture that.
But then other times it acts like these tiny little particles, like bullets of energy,
Okay.
And get this, light is actually both
What?
at the same time. It all depends on how you look at it, how you're observing it. It's like reality itself is just this fuzzy, undefined thing until we go and look at it, until we actually observe it.
Oh, okay, my mind's already starting to bend a little bit.
It's just the beginning.
And I know we can't talk about quantum physics without mentioning Heisenberg's uncertainty principle.
Oh, that's a big one.
That's his big contribution, right?
It's one of the cornerstones of quantum mechanics, that's for sure. And, it says that you can never know both the position and momentum of a particle, like perfectly, with perfect accuracy.
Okay.
The better you get at measuring one of those things, the less you can know about the other.
Oh, so it's like a trade-off.
Yeah, it is.
So if I get this right, this isn't just because our tools aren't good enough.
Right.
It's like a fundamental truth about the universe.
Exactly.
We can't ever fully know everything, for sure. That's kind of wild.
It is. The uncertainty principle, it introduces this fuzziness, kind of randomness right into reality itself. And that changes things, right?
Yeah, because then if there's this randomness, we can't predict the future.
Nope, not with perfect accuracy.
It's not like a clockwork universe anymore, is it?
It's more like a game of chance.
Okay, that's a pretty big shift, isn't it? From what we thought before with classical physics.
Oh, yeah, it's a huge shift. And it makes you wonder, about free will.
Oh, yeah.
About cause and effect.
And just what we can even know at all.
Well, it's just a big question.
Yeah. So if there is this inherent randomness at the quantum level, does that mean that we really do have free will?
That's a big one.
Or is everything still predetermined in some way?
Philosophers have been debating this stuff for centuries, and now quantum physics just throws a whole new wrench into the mix.
Right. Like they didn't have enough to argue about already.
Exactly.
Like quantum physics is making their jobs even harder.
Well, maybe a little bit, but it's also giving them new tools, new perspectives. Quantum mechanics forces us to rethink some of our most basic assumptions about the universe, about how it works.
I mean, that's exciting in a way, right?
It's definitely exciting.
So if uncertainty is just baked into the universe, it makes me wonder about the role of the observer.
Ah, yes.
Does the act of us watching something, does that actually influence reality somehow?
It's a big question. You're talking about the observer effect.
Yeah, the observer effect, yeah.
And, it's one of the most intriguing and debated aspects of quantum mechanics. And yeah, it suggests that the act of observing a quantum system can actually influence its state. It's like reality is waiting for us to make a choice.
Okay.
Almost like it's waiting for us to decide what it's going to be.
So we're like participating in creating reality just by looking at it.
That's a really mind-bending concept. And it leads to some really, really deep questions.
Okay, like what?
Like, does the universe, does it even exist independently of us, the observers? Or does our consciousness, our minds, do they play a role in actually shaping reality? These are the questions that quantum physics is raising, questions that blur the lines between science and philosophy.
I feel like we're just scratching the surface here.
Oh yeah, we're just getting started.
And it's already turning everything I thought I knew about the universe upside down.
Buckle up, because next we're going to explore one of the most baffling and counterintuitive concepts in all of quantum mechanics.
Oh, there's more.
Oh yeah, we're just getting warmed up.
Okay, hit me.
The phenomenon of entanglement.
Entanglement. Okay, that sounds like something straight out of a science fiction movie.
It kind of is.
Okay, I'm ready. Let's dive in. Okay, entanglement, you said.
Entanglement.
It sounds kind of spooky.
It is, a little bit.
So what is it exactly?
Okay, imagine, right, two particles, but they're linked together.
Okay.
But in a way that we don't usually see, like, it goes beyond our normal ideas of space and time. And no matter how far apart these particles are, I mean, they could be light years away from each other.
Wow.
They're still connected. So if you change something about one particle, instantly the other particle, it changes too to match the first one.
Whoa, wait, so they're like communicating.
It seems that way?
But that would mean they're communicating faster than the speed of light, right?
Yeah.
But that's impossible, isn't it?
Well, you're right. Einstein's theory of relativity says that nothing can travel faster than light.
Right.
But entanglement, it seems to defy that. And even Einstein, he called it spooky action at a distance.
Spooky. Yeah, it's a good word for it.
It challenged how he understood the universe, and it's still a bit of a mystery to physicists even today.
So it's like these particles have a secret.
Yeah, it's like they have this hidden connection.
Like a secret tunnel or something.
Yeah, like a shortcut through reality that lets them talk to each other instantly no matter how far apart they are.
Okay, so then instead of thinking of the universe as just a bunch of separate things, this entanglement idea, it suggests that maybe it's more like a big web
Right, exactly.
where everything is connected, but in ways that we don't totally get.
It suggests that maybe the universe isn't just a collection of separate parts, but it's more like one giant interconnected whole?
So then is there something bigger than us, something that connects us all together?
Well, entanglement does kind of hint at that, at a deeper level of reality where everything is interconnected.
That's pretty profound.
And what's really interesting is how this connects with a lot of ancient philosophical ideas, about oneness and interconnectedness that you see in different spiritual traditions.
Oh, wow. So it's like modern science is catching up with some of these old ideas.
Yeah, exactly. It's pretty amazing how science is finding evidence for things that people have been talking about for centuries.
So if this entanglement suggests this deep connection, does it mean anything for, our everyday lives?
It's a great question. And, scientists are still figuring out all the implications of entanglement, but there's a lot of potential, especially in fields like computing and communication.
Oh, okay, how so?
Well, imagine computers that can do calculations way faster than anything we have now, like exponentially faster.
Really?
Yeah, by using the power of entanglement and communication systems that could send information instantly, like across the galaxy with no lag or interference.
That's like straight out of Star Trek.
It is, right. We're talking about a potential technological revolution.
Oh, wow. Sign me up.
And it all comes from these strange quantum phenomena like entanglement, these things that make us rethink what we thought we knew about the universe.
It's amazing, really. But before we go too far into the future, we have to talk about this measurement problem you mentioned before.
Oh, yeah, that's a big one.
What is that all about?
So the measurement problem, it's one of the most mind-boggling things in quantum mechanics. It comes from the fact that quantum systems, they exist in this weird state called superposition.
Superposition.
Meaning they can be in multiple states at the same time.
At the same time.
Until they're measured, until someone observes them. It's like imagine a spinning coin.
Okay.
Until it lands, it's both heads and tails.
I guess so.
Right. But the act of looking at it, of measuring it, that forces the coin to choose to become either heads or tails,
Thanks.
right? And that's kind of what happens with quantum systems. The act of observing them forces them to pick one state. And that's called collapsing the wave function.
Oh, okay. So it's like reality is this fuzzy cloud of possibilities, and then we come along as observers and we force it to take a specific shape.
Yeah, that's one way to think about it, but it raises a really big question, like what counts as a measurement? Does it have to be a person who's observing, or could it be a machine or even another particle? And what does that tell us about reality itself? Is it really there before we look at it?
It's almost like the measurement problem is really about consciousness.
Yeah, kind of.
Is it our minds that are actually shaping the world around us just by looking at it?
Well, that's the big question, isn't it?
Yeah.
And there are a lot of different interpretations of quantum mechanics, and each one offers a different answer to that question.
Okay, so which interpretation is right?
Well, that's the thing. There's no single answer. One of the most famous interpretations is the Copenhagen interpretation.
Oh, yeah, I've heard of that one, but doesn't it kind of avoid the whole consciousness thing?
In a way, yeah, it focuses more on the role of the observer, but it doesn't really go into the details of what consciousness actually is. It just says that a quantum system is in this superposition until it's measured, and then the measurement collapses the wave function into one state.
Right, so it's not really telling us what consciousness is or how it works.
Exactly. But, the Copenhagen interpretation is just one interpretation. There are many others, and each one gives a different perspective on the measurement problem and the role of consciousness.
Okay, so if the Copenhagen interpretation doesn't really satisfy us, what other interpretations are there? What other explanations do physicists have for this whole measurement problem?
Well, if you're ready to go even deeper down the rabbit hole, there are some even more mind-bending interpretations out there. One that's particularly interesting is the many worlds interpretation.
Many worlds. Okay, that sounds interesting. Tell me more.
So the many worlds interpretation, it says that every possible outcome of a quantum measurement, it actually happens, but in different parallel universes. So instead of there being one reality, there's a whole multiverse with infinite possibilities existing all at the same time.
Whoa, hold on. So you're saying that there could be countless versions of me out there, each one living out a different choice I could have made?
Yeah, exactly. It's like every time you make a decision, reality splits and a new universe is created where you made the other choice.
That's a lot to take in, and honestly, a little scary.
Yeah, it's a pretty wild idea.
But if it's true, how can we ever prove it? I mean, can we ever actually see these other universes?
That's the tricky part. The many worlds interpretation is a really elegant way to explain the measurement problem, but it's almost impossible to test experimentally. We can't directly observe these other universes, so for now it's just a theoretical concept.
Okay, so maybe many worlds is a bit of a stretch, but it definitely gets the imagination going.
Oh,
Are there any other contenders for the weirdest interpretation award?
well, there's one that tries to bring back the idea of determinism, that everything is predetermined. It's called pilot wave theory.
Pilot wave. Okay, so instead of everything being random like we were talking about before, pilot wave says that it's all planned out.
Yeah, basically, it says that particles, they always have a definite position, even when we're not looking at them, but their movement is guided by this hidden pilot
A
wave.
pilot wave, huh?
And this pilot wave, we can't directly detect it, but it controls how the particles move, so it makes things seem random, even though they're not really.
Oh, okay, so it's like there's this hidden force, this cosmic GPS system that's telling the particles where to go.
Yeah, you could think of it that way.
It's an interesting idea, but what is this pilot wave? Where does it come from? And if we can't see it, how do we know it's really there?
You're right. Those are some big questions. And pilot wave theory has its own set of challenges and unanswered questions. It just goes to show that we're still figuring out quantum mechanics. There's still a lot we don't know.
Yeah, it seems like every answer we find just leads to more questions.
That's science for you.
But that's what makes it so fascinating, right? This constant exploration, trying to understand reality.
Absolutely. And this exploration, it takes us beyond just physics.
Okay.
It goes into philosophy, too.
Right.
Quantum mechanics, it makes us face some of the biggest questions humans have ever asked.
Uh-huh.
What is reality? What does it even mean to exist? And what's the role of our consciousness in all of this?
I feel like we keep coming back to consciousness.
It's a big one.
Yeah, it's almost like quantum mechanics isn't just about science. It's about like a deep philosophical look at our place in the universe.
It is. And speaking of philosophy, we can't finish this quantum adventure without talking about the elephant in the room, the connection between quantum physics and consciousness.
Oh, yeah, that's the big one. So what does quantum mechanics tell us about our minds, our thoughts, our sense of self?
Well, that's what we're going to explore next, the place where physics, philosophy, and the mysteries of the mind all come together.
Okay, I think I'm ready. Let's do it. Okay, so we've talked about some pretty mind-blowing stuff already. Wave-particle duality,
Mm.
entanglement, that measurement problem.
Yeah, we've covered a lot of ground.
And it's pretty clear that quantum physics, it really challenges how we think about reality, you know?
It definitely shakes things up.
But now we're going even deeper into this connection between quantum physics and consciousness.
Yeah, this is where things get really interesting.
So what can quantum mechanics tell us about our minds, our thoughts, even our sense of self?
Well, that question, it's been around for centuries. Philosophers and scientists, they've been trying to figure out what is consciousness? Where does it come from? How does it fit in with the physical world?
It's a big one.
It is. And for a long time, people thought that consciousness was separate from physics, like it was just a subjective experience that couldn't be explained by science. But quantum mechanics, it's making us rethink that.
Really?
Yeah, it suggests that consciousness might be more connected to the fabric of reality than we ever thought.
So are you saying that quantum physics might actually help us understand consciousness?
It's a possibility, and it's a pretty exciting one, right?
Definitely exciting, but also a little intimidating.
Oh, for sure.
But what makes scientists think there's a connection in the first place?
Well, remember that observer effect we talked about?
Yeah, the idea that just looking at something can change it.
Exactly. And that suggests a link between consciousness and the physical world, right?
Okay, I see where you're going with this.
If our minds can collapse the wave function, does that mean we're actually shaping reality just by observing it?
That's pretty wild.
It is. But are there any theories that actually explain how consciousness could come from these quantum processes?
Yeah, that's what I'm wondering.
Well, one of the most well-known theories is called orchestrated objective reduction, or
Or jour, okay.
yeah, it was developed by Roger Penrose, he's a physicist, and Stuart Hameroff, an anesthesiologist.
Anesthesiologist. That's an interesting combo.
It is, and they think that consciousness comes from quantum computations happening inside these tiny structures in our brain cells called microtubules.
Microtubules, those are pretty small.
They are, but Penrose and Hameroff, they believe these microtubules can hold quantum states long enough for these quantum processes to occur. And they think those processes, that's where consciousness comes from.
So it's not just electrical signals in the brain, it's quantum events with all their weirdness happening inside us.
Exactly.
I can see why that's a controversial theory.
Oh, definitely. It challenges a lot of what we thought we knew about the brain, but tour, it's not the only theory out there.
Okay, what else is there?
Well, some physicists think that quantum entanglement, that might play a role in how our brains work.
Entanglement, the spooky action at a distance thing.
The one and only.
But how could that be happening inside our heads?
Well, imagine if the neurons in our brain, if they could become entangled,
Okay.
it would allow them to communicate and process information in ways that we don't fully understand yet.
That's interesting.
Right. It could be how our brains do such complex things like recognizing patterns, making decisions, even experiencing the world as a whole, even though there are billions of neurons involved.
So it's not just individual neurons firing. It's more like our whole brain is working together as this giant quantum network.
Exactly. And that raises another question.
Okay, I'm ready.
Could this entanglement go beyond our brains?
Whoa, hold on. Go beyond our brains.
Yeah, like could it connect us to other minds?
Like a hive mind kind of thing?
Well, maybe some people even think it could connect us to some kind of larger cosmic consciousness.
Okay, now we're getting really out there.
It is pretty out there, but it's fascinating to think about, right?
It is, but is there any evidence to support these ideas? Or is it all just, speculation?
That's the tough part about studying consciousness. It's subjective, so it's hard to measure it scientifically.
Right.
But there have been some interesting experiments where researchers saw correlations in brain activity between people who were meditating together, even when they were far apart.
So, like, their minds were becoming entangled.
It's a possibility, but we need more research to say for sure.
So it seems like we're still a long way from fully understanding consciousness.
We are, but that's part of the journey, right?
I guess so. Well, after this deep dive into quantum physics, it's definitely clear that the universe is way more mysterious than we could have imagined.
Yeah, we've barely scratched the surface.
We've talked about things that challenge our understanding of reality, time, even our own minds.
And we've only just begun to explore the possibilities.
Exactly. So to our listeners, keep asking questions, keep exploring, keep that curiosity alive.
Because quantum physics shows us that there's so much more to discover.
Yeah, the universe is full of wonder and mystery, and the more we learn, the more we realize how much we still don't know.
And that's the beauty of it.
Thanks for joining us on this deep dive into the quantum realm.
It's been a pleasure.
Until next time, keep those minds curious and keep questioning the nature of reality itself.